Welcome to the WION podcast. You know, we often think about the universe, this huge, maybe infinite thing, but what if the end isn't quite as far off as we used to imagine?
That's exactly what some new research is suggesting. It's fascinating, really.
Yeah.
The old estimates for when everything just stops were almost unimaginably vast.
Like practically forever, right? Numbers with thousands of zeros.
Exactly. We're talking timescales like 10 to the power of, well, over 1,000 years. But this new work dials it back quite a bit. Still huge, mind you, but different.
Okay, so how different are we talking? What's the new number?
The estimate now is around 1 quinvigintillion years. That's a 1 followed by 78 zeros.
78 zeros, okay.
Yeah.
Still feels like forever, but definitely smaller than thousands of zeros. So what changed? Why the revision?
Well, it comes down to looking beyond just black holes. We've known about Hawking radiation for a while, the idea that black holes aren't actually permanent. They sort of evaporate very slowly.
Right, they leak energy over cosmic time. Stephen Hawking's big idea that kind of contradicted Einstein in a way.
Precisely. Black holes aren't truly black or eternal sinks. But the researchers, this team from Radboud University in the Netherlands, they started thinking, well, what about other really dense objects, things left over after stars die?
You mean like neutron stars? Or white dwarfs, like our sun will become eventually?
Exactly those. Neutron stars are incredibly dense remnants of massive star supernovas, and white dwarfs are the cores left from smaller stars. The thought was, maybe they don't last forever either.
Huh. So they evaporate too, like mini black holes almost.
Sort of, yeah. The idea, pushed by researchers like Heino Falke there, is that this Hawking radiation concept might not be exclusive to black holes. Maybe any object with a strong enough gravitational field, depending on its density, eventually radiates away its mass.
So previous models just missed that. They assumed these stellar corpses would just hang around indefinitely.
Pretty much. The focus was heavily on black hole evaporation as the final act. This new work suggests that neutron stars and white dwarfs also have a finite lifespan, governed by a similar, though likely even slower, evaporation process.
Wow. Okay, so it's not just the exotic black holes, but even the more common dead stars that eventually dissolve into nothing.
That's the implication. It paints a picture of a universe where everything eventually decays, even these incredibly stable-seeming remnants. It's a more complete view of cosmic decline, perhaps.
A quinvigintillion years. Yeah. It's still almost impossible to wrap your head around that time scale.
Mm-hmm.
But knowing there's a more defined end based on this broader decay mechanism, that's quite something.
It really refines our understanding. It shows how dynamic the universe is, even in its very, very deep future. Nothing's truly permanent.
A humbling thought, definitely. Well, that gives us plenty to ponder about the ultimate fate of, well, everything. Stay tuned for more such intriguing stories to come on the WION podcast.